Hey there. Ready to unlock a hidden language,
Sounds intriguing. What language is that?
the language of force and pressure. It's how things move and interact. Everything from, like, that phone you're holding to
Yeah.
the entire universe, really.
That's a pretty wide range. So, what's the plan for our deep dive today?
Well, we want to go beyond just knowing the definitions of force and pressure.
Okay, get into the nitty gritty.
Exactly. We're going to try to actually feel them at work all around us. And honestly, I love this topic. Makes the everyday world feel kind of magical, you know?
I'm with you on that. It's amazing what we take for granted.
Totally. Let's start with something we're all familiar with, force. You probably already have a sense of it. It's what gets us moving, stops us in our tracks.
And let's be real, sometimes makes us spill our coffee.
Been there. Okay, so picture this. You're pushing a coffee cup across a table. You just used force,
Simple as that.
basically.
Yeah.
In the simplest terms, yeah, it's a push or a pull. But the source material points out that it always involves at least two objects interacting.
Ah, so it's a two-way street, not just about one thing acting on another.
You got it. So with the coffee cup, it's not just you pushing it. That cup is also pushing back on your hand. It's subtle, but it's there. Forces always come in pairs action and reaction.
That's so cool. It's easy to miss that second force, though, because we're focused on what's moving.
Totally. And this pairing is surprisingly powerful. Like, it explains why you can't just float away by pulling yourself up by your bootstraps. You might be applying a force to your boots, but they're applying an equal and opposite force right back on you.
Makes sense. So force is all about interaction, not just some mystical energy making things move on their own.
Exactly. And to really understand how something will move, we need to consider two things. The magnitude of the force, meaning how strong it is, and the direction of that force.
Okay, so both how much oomph and where it's going.
Exactly. Imagine playing soccer. You kick the ball toward the goal.
Yeah.
The harder you kick it, the greater the magnitude of the force, so the faster the ball goes.
But then there's the goalie, right? Using force to try and stop that ball.
You know it. Pushing it in the opposite direction. It's like a constant force battle happening all over the field.
Now that you mention it, even something as simple as pushing that coffee cup across the table, it involves a bunch of different forces at play, doesn't it?
You're reading my mind. There's your push, the friction between the cup and the table. Even a little bit of air resistance, though it might be slight.
And all of that affects how that cup moves.
You've got it. And it brings up another key point. Force can change an object's state of motion, can set something in motion, like that soccer ball, or bring it to a stop, like that coffee cup eventually coming to rest. And as you pointed out, friction, the force that opposes motion, plays a big role in that.
It's like a constant battle of forces. So, thinking back to the coffee cup example, if I push it with my whole hand, it moves easily enough. But if I try pushing it with just the tip of my finger, it takes a lot more effort, even though it's the same cup. Is that related to this pressure idea?
That is such a good observation. You're already connecting force and pressure, even though we haven't really gotten there yet. You're right, the area over which a force is applied makes a huge difference.
So it's not just about how strong you're pushing, but also about how spread out that push is.
You got it. We'll definitely dive into the specifics of pressure in a bit. But first, let's unpack another layer of complexity in the world of forces contact versus non-contact forces. So far, we've been talking about force as like a direct push or a pull,
I
right?
think we were talking about that soccer ball.
Exactly. But this source material points out this really cool distinction between contact and non-contact forces.
Okay, and I'm guessing that's where things get a little more complicated.
You could say that. Think about that soccer game again. When your foot connects with the ball, or the goalie's gloves deflect it. Classic contact forces.
Because there's actual physical contact.
Exactly. Muscles doing the work, coming into direct contact to exert that force.
Makes sense. So what about the non-contact forces then?
Well, that's where things get kind of mind-blowing. These are forces that seem to act at a distance, almost like magic. The source mentions magnetic force, which I think is a perfect example.
Oh, yeah. Like you can hold a magnet near a paperclip and without even touching it.
The paperclip just leaps towards it.
It's like an invisible force field or something. It really does feel almost supernatural when you think about it.
Totally. And the source mentions another non-contact force too, electrostatic force.
Now, remind me what that one is again.
You know, you ever rub a balloon on your hair and then it sticks to the wall?
Oh, yeah, right.
That's electrostatic force. You create a static charge, and suddenly that balloon can attract or repel other objects without any direct contact, like it's breaking the rules or something.
It's wild. And actually, isn't there the biggest, most obvious non-contact force we experience all the time? Gravity.
You got it. The one and only. The force that keeps our feet on the ground and dictates how planets move. You know, it's funny. We experience gravity constantly, every single day. But it's so ever-present that it's easy to forget just how mind-boggling it really is.
It really is when you stop and think about it. The source actually asks, have you ever wondered why it is so? Like, why does an apple fall from a tree? Why do things naturally want to go down? It's such a simple question, but...
But it's a question that has fascinated scientists and philosophers for ages. We know gravity is this invisible force that pulls everything towards each other, but we still don't fully understand its true nature. It's like this profound mystery we encounter every single day without realizing it.
But even without knowing all of gravity's secrets, it's amazing how much we can explain just by observing its effects.
Right. Like it's what makes that waterfall rush down, it's what causes the tides to go in and out, and it's what keeps our planet orbiting the sun.
It really puts things in perspective, doesn't it? Just understanding a bit about force, like contact versus non-contact forces, can totally change how we see the world around us.
Absolutely. And you know what else is interesting about gravity? It always acts over a distance, just like those magnetic and electrostatic forces we were talking about.
Oh yeah, the whole action at a distance idea.
Exactly. This really baffled scientists for a long time. They couldn't figure out how one object could exert a force on another without actually touching it.
I mean, it seems impossible. But eventually, by studying these invisible forces, scientists started to come up with new models and theories to try to explain them, right?
Exactly. And those theories then went on to lead to some of the most groundbreaking technologies we have today, from things like wireless communication to medical imaging.
Wow. So tackling those big fundamental questions really can lead to some incredible places.
No doubt. And speaking of fundamental questions, you remember how you were talking about pushing that coffee cup with your fingertip versus your whole hand earlier?
Yeah. Yeah, it felt like it took way more effort with just my fingertips.
You're so right. And that's because you were already intuitively understanding the relationship between force, area, and pressure.
So I was right. It's not just about how strong you push, but also about how that push is distributed, right?
You got it. And that, my friend, is pressure in a nutshell. The source material describes it as force distributed over a particular area, meaning it's about how concentrated that force is.
I think I'm starting to get it now.
And this is where pressure gets really interesting, because it's not just about us pushing on things, or even those invisible forces. It's everywhere, you know, even in the air we breathe.
Wait, really? We don't feel air pushing on us, though.
That's the wild part. Remember how we were talking about gravity pulling everything down? Well, imagine that force acting on all the air above us, like a whole column of air.
Okay, and air has weight, right? So.
Exactly. It's pushing down on us with a lot of force. And we call that atmospheric pressure.
So it's like we're at the bottom of an ocean, but instead of water, it's...
air. An ocean of air. Crazy, right? And the source material talks about how much weight that actually is pushing down on every little bit of us.
Okay, so how much are we talking here?
At sea level. About 14.7 pounds per square inch. That's a lot.
Whoa. It's kind of mind-blowing that we don't feel that. Why don't we feel crushed by all that weight pushing on us all the time?
Because the pressure inside our bodies is pushing out with the same amount of force, so it balances out. We're like walking around in this constant invisible tug of war, and we never even notice.
That is wild. But even though we don't feel it directly, atmospheric pressure still affects us, right?
Big time. Think about it. It lets us breathe. It helps our blood move around. It even influences the weather.
Oh, wow. So what about when that pressure changes? Like, what happens then?
Well, that's when you really start to notice it. Like, ever been on a plane and your ears pop during takeoff or landing?
Oh, yeah, definitely. Is that related to atmospheric pressure?
Absolutely.
Yeah.
As you go higher, there's less air above you, so the pressure drops.
Ah, so our ears are just trying to adjust to those changes.
Exactly. Our bodies are constantly adapting to all these shifts in pressure without us even realizing it.
I guess we take it for granted until something feels off. So this pressure difference is why planes can fly, right?
You got it. It's also why things like vacuum cleaners work. They create a low-pressure area inside, and the higher atmospheric pressure outside pushes the air and dirt in.
Wow, it's kind of like this invisible force constantly at play, shaping our world in ways we don't even think about.
Exactly. The source even mentions this really cool experiment that demonstrates atmospheric pressure in a dramatic way you ever hear of Otto von Guericke and his hemispheres.
It rings a bell. Didn't it involve horses or something?
Yeah. Back in the 1600s, Guericke, this German scientist, he designed these two metal hemispheres like halves of a sphere that fit together perfectly. Then he used a vacuum pump, which he also invented, to remove all the air from inside.
Creating that low pressure area inside? Okay, I see where this is going.
Right. So he's got these two halves stuck together just from the air pressure. And get this, he hooks up teams of horses, like 8 on each side, to try and pull them apart.
No way they couldn't pull them apart, could they?
Nope. The force of the atmosphere pushing the hemispheres together was so strong, even those horses couldn't budge them.
That's insane. That really puts the power of atmospheric pressure into perspective. It's invisible, but it's strong.
It really is incredible. And, this all circles back to what we were talking about earlier, force, pressure, area. These aren't just textbook terms. They're the fundamental building blocks of how our world works, from the tiniest things to the biggest.
It's like this whole hidden layer of reality that's been there all along.
Right. So next time you see a balloon inflate, or feel the wind on your face, or even just take a deep breath, I hope you'll think about those invisible forces that make it all possible.
Totally. It makes you look at the world a little differently.
Exactly. Well, there you have it, our deep dive into the world of force and pressure. From the basics of pushes and pulls to those mind-boggling invisible forces and atmospheric pressure. Hopefully you've walked away from this not just understanding it better, but maybe feeling a little bit of awe and wonder about how amazing our physical world is.